All right, everyone. In the interest of time, we will begin. I know you guys have a busy day. So, again, hello, everyone, and welcome. Thank you for taking the time out to join us today and for being with us, our first webinar dedicated to the English speaking Caribbean, hosted by JA Solar. It's a great pleasure to be with you today, and we truly appreciate your time and participation. To start off, let me introduce you to our team for today's session. Our main presenter will be Pablo Munoz, our technical manager for Mexico. Now, while Pablo primarily oversees Mexico, he also provides technical support throughout the LATAM region. He brings extensive experience in technical construction, supervision, and commissioning, having worked on renewable energy projects totaling over 950 megawatts. He has strong focus on photovoltaic systems. And then, of course, you have myself, Rayon Whitaker, the sales manager for the English-speaking Caribbean region. I work closely with distributors, utility scale projects, and commercial and industrial clients across the region, helping to drive solar adoption and provide tailored solutions. Now, for today's session, we're going to focus primarily on bifacial solar modules. Reason being, we've identified that there's some common misconceptions and a need to further bring some education around this technology. So our goal for today is to provide clarity and to help you better understand the benefits and applications of bifacial solar modules. Now, as we go through the presentation, we encourage you to engage with us. If you have any questions, feel free to drop them in the chat. We have our technical manager for the LATAM region, Guillermo, who is present. We'll address those questions during or after the session. And also, we ask to stick around for as long as possible because we have a trivia session where there will be a winner announced, and that winner will get a gift. That's a Brady printer. So we ask you to stick around for that session. All right, so we'll now get started. More information on Pablo. And of course, myself. Now, before we dive deeper into today's discussion on bifacial modules, I want to highlight why JA Solar is a trusted leader in the solar industry. So I'm gonna dive deeper more into go more into this. We were founded 20 years ago in 2005, and JA Solar has grown into a powerhouse in the PV sector. We have a strong global presence, being listed on the NASDAQ exchange since 2007 and the Shenzhen Stock Exchange since 2019. Now, in 2023 alone, we generated 81.5 billion RMB, which is approximately 11 billion US dollars in revenue, and we continue to expand our market reach. Now, our cumulative shipments reached 242 gigawatts. That's approximately 500 million solar panels shipped, and we covered over 178 countries and regions. Now, we ensure a full control over our solar manufacturing process, enabling a complete traceability from raw materials to the final solar module. Now, why does this matter? This ensures that our product quality and consistency, or ensures product quality and consistency. It supports sustainability and ethical sourcing, and also provides complete supply chain transparency. So our vertical integrated model guarantees that our customers will receive high quality, traceable, and sustainable solar solutions. Next. Now, from this slide, you can see where we've established a strong global presence with commercial operations and storage facilities in key regions worldwide. Why is this important? Because with a strong international market presence, this ensures reliable supply chain and customer support, and the growing global installation reinforces brand trust and technology leadership. Also, regional storage and commercial operations enable efficient logistics and service from us. Also, we've ranked among top global solar companies. Just last year in 2024, we received a #3 ranking by Wood Mackenzie. We're also recognized for excellence in module manufacturing and a strong manufacturing capacity, vertical integration, and research and development investment. In the first half of 2024, we're top 2 in global shipments, and we shipped approximately 35 gigawatts for the first half of 2024, and an expected 85 to 95 gigawatts for the entire year of 2024. Now, again, what's important is our strong strategic alliance with global companies worldwide, ranging from Samsung, BYD, number of plants that we have set up around the world, and also EPCs participating in projects around the world. From here, you can see plants that we have our modules invested in. So just to name a few, we have a 100 megawatt plant in Guatemala, in Dominican Republic, that's close to, right within our Caribbean territory. We have a 58.5 megawatt plant. In Mexico, we do have a few large ones, 232. In Colombia, we have a 356 megawatt plant, and so many more. You can go to the next slide, please. To continue, in Panama, in Colombia, in Brazil, we have plants ranging from 90 megawatts up to 412 megawatts. So our modules are stretched right across the region in vast projects. Now, going to our certifications, JA Solar is officially classified as a Tier 1 solar module manufacturer. And we're highly recognized for financial stability and bankability and large-scale project adoption. Now, why does this matter? Because industry recognition confirms JA Solar's leadership in quality and performance, and we'd like to maintain that. Also, high shipment volumes reflects our global trust and the demand. So now with that, let's transition to our core topic, bifacial solar modules and their advantage. Pablo, we turn it over to you.
Okay. Hello, everyone. Happy to be here, and happy to talk about this this important matter. As Rayon talked about it in early stage of the presentation, there are a lot of things and a lot of misunderstandings regarding the use of bifacial modules. I think it's the new tendency for DG, CNI, and utility projects to follow up. If you can slide to the next slide, please. As you can see, the tendency of usage of this type of module, it's getting bigger, it's getting greater. So the first technology based on, wait, let me see something. The first tendency to get sorry. In some instances, you can see in this graph the tendency of usage of bifacial modules. It's really big. It's getting greater. You know, the first instance of doing or using monofacial modules was to provide or to have a plastic cover at the back. Right now, using dual glass covering will give more mechanical and more reception generation. Sorry for I'm a little bit sick. I wanted to cough, so I'm trying to get this control. In some instance, the bifacial modules are, as I said, are the big tendency to use down on big and small scale projects. Can you switch to the next slide, please? Okay, the construction of or the difference between the bifacial module and the monofacial cell. The monofacial cell only covers the front part of the module. Okay, the back part, it's not active, it's not really usable. But in the bifacial module, we're having both sides of the cell with active and having generation. In some instance, this gives a lot of energy production down to the module and to the project needs. Yes, in the having both sides active will rely on having more power down to the necessities of the, I don't know, to the client, to the grid. In some instance, in my experience, having both sides of the module active will give more power or more amperage down to the circuit or to the string. Yes, and it will help a lot to ensure its performance. Monofacial is, as I said, it's a technology that might be living in the next 5 to 10 years. Regarding the material they use as the back sheet. Could you change to the next slide, please? This is a deconstruction of the module, the stages or the parts that are related to each type of module, no type of technology. Monofacial module, the convention, it has a aluminum frame, front glass, EVA, transparent plastic. I will talk about more EVA in the next few slides. The silicon cell, another layer of EVA, the backsheet film, and the junction box. In some instance, as I told them, I think the most reliable or in this technology is the backsheet plastic film. When during my first installations here in Mexico, we needed to have a lot of to take care of that type of module, because if it scratches, if it has any damage at the back, the module might suffer at the end a lot of issues, or maybe that module is no longer viable to be used on the on the PV array. You know, scratching it, breaking it, it's really a problem. to make this module work. So you need to take a lot of care about it, you know. And having this type of module on utility projects, and having a lot of people handling it and installing it, might cause a lot of issues to break that backsheet plastic part. For the bifacial module, I know everyone thinks it's gonna grow bigger on weight, and we're gonna have problems. Right now, having both sides active and having both sides covered by glass, it gives more it's more reliable to handle, and you don't have to take care of that problem of of scratching or breaking that plastic sheet. I know you will say glass is really brittle. It resists. It takes it to a next level of mechanical and an installation grade. As you can see, the bifacial module, it's constructed by an aluminum frame, a front glass, EVA transparent plastic, cell, the other EVA transparent plastic, the back glass, and the junction box. Okay, so this will make a little bit more interesting the usage of modules, of solar modules, down to different applications. And I will talk it further in the presentation. Can you turn to the next slide, please? Perfect. Monofacial modules. The monofacial modules, direct light absorption, it only generates from its front side. You can apply it down to coplanar or to rooftop direction. Yes, it doesn't matter. It has, yes, it's lighter than the bifacial module, but it doesn't gain from the back part. I know you will say bifacial modules placed on rooftops with the same alignment, you will not use the back part of the module. I agree with that, but sorry, but sometimes you could use it on planar on steady slopes, you know, on fixed rooftops where you don't have a slope, and you can use that part of the module, right? And in some instance, the usage or the difference, it doesn't comply only by the weight. I understand, as I was saying, the having two sheets of glass might have a lot of weight, but right now we're getting bigger or more efficient models with bigger power ratings, so you can compensate. Bifacial modules with more energy production, with more efficiency, will cover less area, and less area will give you less weight on top of the rooftops. Next slide, please. As I was talking about the mechanical properties of the module, it's even greater to have a two-sided glass module. This gives more it makes it more how I can say it in not so technical, sorry. It gives an equal pressure point values on a bifacial than on a monofacial. As you can see on the graph, the distribution of loads is even more equal in the 4 points of normal 4 points of fixation of a bifacial than in a monofacial. Yeah, you have less risk of micro cracks than on the monofacial. The monofacial only has one cover that gives this mechanical resistance down to the whole module. Okay, having an equal sided like sandwich will give more it will give equal points of pressure in the module. Sorry for but I'm trying to have it more plain, not so technical. Can you change it to the next slide, please? Perfect. This is the big question. Using the bifacial modules down on rooftops, you will not the back part of the module will not be really reliable on the power production. So in some instance, the weight, the area, I will not be using the back side of the module. I understand that part, but as I was telling you, they are bigger or not bigger. They have more power more power absorption area. We will have more bigger power bin modules, and that will give you that would make you use less modules in those types of areas, and those areas will be compensated for the weight using fixed ground structure. In some instance, in the past, I didn't agree to use bifacial modules on fixed structures. Why? There is a lot of steel at the back of the module, and there's a lot of shadow at the back of the module. So you will not have a lot of light absorption, and you will have a lot of shadow at the back of the structure. But right now, having a lot of studies and having specialized people doing this albedo studies to see how it works, it not only depends on the structure that you place the module in. It also refers to the type of ground or reflective material that you have at the back. So we cannot rely on having as we say, the 80% of back light absorption, but we can rely in some grade of power absorbed, so we can have more power down to the front side of the module. Can you turn to the next slide, please? Sorry. Hotspots. In the bifacial, we can rely on really low concentration of temperature on the module. As I've said on the previous slide, we have an equal sandwich, and those two layers of glass permit a really good flow of heat around the module. Okay, so having those two sheets of glass will decrease in some instance the temperature flow inside the module. Having the back sheet in plastic will concentrate in some way, as you can see on the picture in the presentation. You will have concentration of heat. If there's a breakage of that plastic sheet, you can have those type of issues, and then you will have to replace the module on your PV array. So considering this, it's even more efficient in managing and on power production a bifacial module than a monofacial. I know that we still use it. I know that we in some instance here in Mexico, it's a very it's the favorite product to have, the monofacial, but it has a lot of risks right now and might be really not covering the necessities of the client. Right now, the tendency, as we were talking about, the tendency is flowing back, flowing to the bifacial module. Can you turn to the next slide, please? Fire safety class. This is really important. This, I think every one of you asks if we have the Class C or Class A, the UL Type 1, the UL Type 29, or why we have changed from class A to class C, or UL type 1 to type 29. This comes from a change on the standards regarding the UL type fire class rating, okay? So we have now a safer module referring to the bifacial, because we do not have materials that can ignite or promote the fire on if there's a fire nearby, or ignition materials. Having two sides of the module performed by glass or constructed by glass will give this quality to the module. It will reduce the ignition process of the module. Having the plastic one, it will go down to a really it will promote the fire if it's existent during the fire. So this advantage will give a lot of safety down to the PV project that you're related on. Can you switch it to the next one? Next slide, please. As I was telling you, certification U in type 1, it applies to the material and products used to low or not direct fire exposure applications. These products are not designed for fire resistance, but must meet safety requirements to prevent fire spread. As I was telling you, plastic at the back of the module can have this quality. Certification UL Type 29, it is awarded to materials and products designed for the resistance in specific applications. These products must meet stricter standards and withstand direct fire exposure for a set of period of time. It takes time for glass to ignite, okay? It takes time for the fire to reach the cell inside a bifacial module. So it prevents fire spreading down on the PV array that it's on fire. So we have this benefit. Using bifacial modules will low back or lay back the promotion of fire if it exists. Can you change it, please? Next slide, please. Durability. This is a big issue. Right now, a plant that we showed in the previous slides, they're asking us to have a repowering. They were using monofacial PERC modules. And as I have seen during my inspections, they have a lot of affection in the front side of the cell. They were showing like a red rim around the wafer, and this is related for the use of the backsheet. All the power reception is concentrated on the front part of the cell. So this gives only the front part of the module being affected by light, UV rays that it's also absorbed by the sorry, by the front side of the module, makes a degradation in a higher rate. Okay, so I think that, as I told you, that technology must be replaced by bifacial. So as we can see on the slide, for backsheet, its high impermeability, increases resistance, and a 30-year performance guarantee. As I was telling you and talking about the experience I have, having backsheet will not give you an extended time of warranty on the module. Could you have the next slide, please? Thank you. As I was talking about the EVA, ethylene vinyl acetate, and the polyphene, the POE, This the materials used are also a little bit more expensive. You need to adapt the size of the back film, and having that, it's adapting the roller that contains that type of film, and the production process, it's a little bit more expensive in some way. Yeah. But having both sides of the module with glass, it gives more. You're producing the same size of the front and back side of the glass, and you can reduce these costs. Okay, if there's no plastic, if there's no back sheet, we will need to back up the production. But I think having the same raw material for silicon wafers and crystal glass back and front sheet, it will help us as a company to reduce costs and give a better price down to the final client. The encapsulant in multi-layer film consisting on a thin layer of POE sandwiched between two layers of EVA. This is EPE, okay? The construction of the cell makes the mechanical properties even greater. As I was telling you, the even sandwich of bifacial module gives more effect, gives more mechanical properties down to the module. Can you switch down to the next slide, please? This is a table comparing the characteristics and the properties of the module. The optical and transparency for EVA, it's really high. It allows sunlight to reach the solar cell. The POE, slightly lower than the EVA, but sufficient for photovoltaic applications. And the EPE arrangement, medium, suitable for photovoltaic applications. In aging, it degrades due to UV light. As I was telling you, UV light will affect directly down to the module. For the POE, lower degradation than EVA, which extends performance, and EPE, good resistance to degradation and aging. What do we need about, what we require for the module? The module, we require a long lasting life and performance of the module. So having materials that age really fast on the module will give a lot of issues in the future. You know, warranty claims, the module is not working, the module will not be, in some instance, give me a minute, please. The module will not have this coverage of power generation. I will need to switch it in a few years than the 25 that it relies on. I'm not telling you that the module will not cover those periods of warranty time, but in some instance, sometimes the final client or the installer, they do not have the proper ways to manage the module. Okay, so in having two sides or using bifacial modules will apply down to have long-lasting modules for the PV array that you're installing or you're buying in. Durability, as I told you, useful life of 25 from 20 to 25 DEVA. The POE exceeds those 25 years, and the EPE has the same life expand as the POE. So the construction of the module with these types of layers will give a lot of lifespan of the module, and it will give you more, and the module will be more reliable during its work time. If you can switch it to the next slide, please. as I was telling you, the degradation and warranty lifetime. Light-induced degradation. For this sorry, for this type of module, the bifacial, we have 1% for the first year and 0.4% for the next 29 years. Okay? When you use a monofacial, yes, you will have a light-induced degradation of 2% and a subsequent 0.55% each year from the 24 years that it would last. The bifacial, 30-year guarantee. Monofacial, 25-year guarantee. If you can have 5 more years of light and power production on your module using bifacial, I think that bifacial is the best way or the best product that you can use. Switch it to the next slide, please. This is a very simple comparison. The module JM 606045 LB, the first one, bifacial, the weight 33.1 kilograms, cell 182 by 210, dimensions 2382 by 1134, number of cells 132. As you can see, yes, there's a big difference, almost 4 kilograms between both of both modules. But in some instance, as I have told you, bifacial modules with the same dimension as the monofacial can produce more power, can gain more power. It also depends on the type of structure that you use. I know most of the DG side uses it on rooftop linear installation, and that will not take the advantage of the bifacial. But in those on those type of installations, we can use higher power beam modules, use less modules, and that will compensate the weight difference between both modules. So we can switch that big issue of weight down to power and area coverage. Next slide, please. The bifacial gain estimation. In some instance, as I was telling you, a lot of people in first place thought that the back sheet of the module will produce the whole power that the manufacturer granted or tell them, oh, my back sheet will produce 80%. No, this goes into two different ways. Yes, I have an area exposed with light gain and power gain, but it also depends on the surface that the light reflects on. This type of study is an albedo study. We need to know what type of material are we having at the back of the module so we can rely on that power absorption. We cannot see, I have a really big experience on this. Snow is really, really reflective. I was installing a PV array in the United States. And in some instance, when we were installing it, we had a lot of amperage on it. And we were saying, what happening? What's happening? There was a lot of snow on the ground mount we were installing, and it was said, whoa. That's why I'm telling you, it doesn't only rely on the back part of the module. It relies on the material or the conditions that the module is placed in. Yes. We cannot we cannot go down to the manufacturer and say your module doesn't work. No, it depends on other factors. And if you would like um, to use that bifaciality characteristic on the module, you will need to have an albedo study to perform and see if it's reliable to use it, or only consider the front part of the module. Here in Mexico, in some utility scale projects, they do not rely on the back part of the module. They only rely on the front sheet, but they ask to install bifacial module because of their mechanical properties. Can you switch it back to to the next slide, please? Okay, the calculation referring to the total exposure of the rear side of the module. In some instance, this is mathematics, and mathematics they do not lie. But as I was telling you, we rely on the material, the reflective material that we use, or it's placed on the site where the PV array is going to be constructed. There's some studies that if you have grass, you will have a really low reflective rate. Why? Because the sun, the light, the photon goes into the grass, makes the photosynthesis process, and it would stay there. So you will need to have another type of material to make this reflective or albedo effect even greater. So you will need to switch that. And for that type of material, you will need to have maintenance on it. You will need to cut the grass, to cut any plant, maintain it in white, or maintain it in different colors that are reflective to it. So this calculation is, as I said, it's really mathematical. It gives you an overview of what can happen. Okay, the albedo, it's the amount of reflective light that it can give times the bifaciality of factor of the module. We as JA Solar, we give an 80% for that. The albedo factor, it's 14%. It will give down to an 11.2%. Total irradiance, 100% of the module, down adding up the 11.2 from the back part of the module, and it will give an amperage from an amperage of 16.10. The 14.48, it's the ISC front part. We add up the 16, the 111% of the albedo gain, and we get 16.10 amps. I don't want to be really technical, and I don't want to go down through it, that the cell installed or constructed inside the module works both ways. Don't think that we have two wafers sandwiched up in the same module. We are working with the same wafer, the same cell, but it's acting both sides. So we have both areas active, and we gain amperage down to the module and produce more energy. So as I was telling you, it doesn't only depend on the area exposed of the module, it also depends on the material that we have at the back part of the installation. Can you switch down to the next slide, please? I think if you have used this type of tools, sorry, PVCist, it's a really good tool to use. I like it a lot. And we can add up to the simulation this type of power gaining factor. Okay, we can rely on books, in met information, but to have this in a really strict way and introduce the information correctly down to the PVCist, we will need to have an albedo study on the region or on the place where the PV array will be installed. So, in first place, direct and diffuse irradiation of rear side, diffuse ground factor. As I was telling you, how the ground or the area reacts down to the module. Ground reflection on the rear side, the albedo, what percentage of light reflection we have. There are specialized equipment, pyranometers in GHI, in ground horizon irradiation, global horizon irradiation, and the other ones in plane of array. These pyranometers measure the light absorption or the light that this they measure the light absorbed by the module or by the cell on this equipment, and this will give you ground reflection or the albedo value. View factor, ratio between the area of the photovoltaic module collector and the area of the ground with the reflection capacity. As I was telling you, both sides count. Both sides are acquainted down to the PVCist tool to have an even and calculate how much more power we can gain on the backside. Shading factor of the structure. Using ground mount. There's a lot of steel. There's a lot of structure at the back of the module. How does this shadow affect the bifacial part of the module? Distance between the tables, really important. Why? Because sometimes this distance, the shadow cannot, the shadow from the east or west table can harm this albedo effect. Height above ground, really important. If it's really low, we will not cover or we will not have a lot of reflective material to reflect light down to the back part of the module. These factors, as I was talking to you and telling you about the gain of the back part of the module, are really significant, are really important to get into consideration to use the back part of the module. I'm not saying that the module does not work in all conditions. No, but you need to be really thorough and to see what are your necessities down to site. Having bifacial modules will help you to reduce the area of implantation down to the structures that you may use. So you need to be really to understand the design of the project, the necessities of the project, so you can apply the correct technology. Right now, having these types of considerations, we can apply down to bifacial. It gives you even not the 11%, even the 6% or 5% of the back part light absorption, it will give you power. It will give you this gain of power that sometimes you need to deliver down to your house, to the industry, or to the grid. Next slide, please. I like this this slide a lot because it shows that gain of power. As you can see, the power for 25 years is 46,951 megawatt. In 25 years, having bifacial, we can have 1,000 more megawatts, a little bit less. Well, it's between, no, like 150 megawatts a year in 30 years. That's a lot of power. That's a lot of power. So if you gain that power, if you use that power or you sell that power, it's money on your pocket. It's really using the two sides of the cell in the module, yes, and you can have more performance. You can have more efficiency. You can have more power. As you can see, it's 0.19% more power. And you have a module that lasts for 5 years in warranty process. So I think that using bifacial will increase and help a lot your the necessity that the project may have. Next slide, please. Another example of it, and this gain is even greater. You have a 2.33% power. As I was telling you, it depends on the way you use it. It depends on the way you install it, and the characteristics of the site or the place you're installing it that will give you this bifacial gain. Can you switch it to the next slide, please? The big challenge, and I was talking about this since the beginning, weight. 3 kilograms more. Yeah, but I was telling you, we can compensate it with power production. If we need 10 monofacial modules, I don't know, 500 watt each, and we can use 630, 620 bifacial modules, and you use less, maybe 7, maybe 6, yes, you make an you substitute power for weight. So you don't use the same, or it's equivalent, but you're using less modules. And if you are using it on a ground mount, or you're using it not on a rooftop, you can have more power from the back of the module. So we need to rely on the same measurements, the same length, the same width of the module, but we're having more power produced. So I think the weight will not be a disadvantage for the bifacial if we use with bigger power bin modules for those types of installations. So let's think about it. It's less area to cover, more power to gain. I can put reflective material at the back of the module. I can gain more power from both sides of the module. It's even greater. Okay, next slide, please. Bifacial module application, coplanar photovoltaic energy systems. As I was telling you, this, okay, understood. I cannot use the back part of the module, but I can have bigger modules, not bigger, more power, bigger power bin modules, and I can reduce the weight having that. Instead of using 550, we can use 620. And we can compensate, as I was telling you, the weight. Ground-mounted photovoltaic energy systems with fixed structure. Excellent to use. Yes, we have a lot of steel at the back. We have a lot of shadow. We can use or adapt the back part, the ground or the reflective material to induce that reflection down to the backside of the module, gaining more power. Ground-mounted photovoltaic energy systems with tracker. Tracker always uses bifacial modules because it has a really big area, yes, to have this reflection absorbed by the backside. During my 15 years of experience, I have installed, as Rayon said in the beginning, 900 and something megawatts. I cannot recall it. And every time I've installed a tracker system, they use bifacial module. This bifacial module and the area exposed down to the ground, even though if it's grass, if it's sand, if it's stone, whatever, it gives a lot of gain down to the power to the grid. It's an excellent product to use on tracker systems. Next slide, please. As I was telling you, here in Mexico, we have around 1.9 gigawatt with JA Solar installed around the country. And most of it, it's tracker, and the most of it is bifacial. We have fixed structures in Brazil. We were talking about the height. It's really important to have it. This, they put it in a higher, they put it higher so we can have more albedo, more reflection down from the backside. Co-planar rooftop in Panama. This one, as I was telling you, they were trying to use a 550 module from another brand, and we tried to come with them and help them to perform in less area with a bigger power bin modules. So we covered the necessities of the client. Yes, we did not increase the weight on the structure, and we were using the mechanical properties of the module on this type of installation. Fixed structure in Brazil, again, the same thing. We can use the backside and the material of the ground or the area to reflect the light up to the back part of the module. As you can see, the Ford structure in Brazil, it doesn't have a lot of metallic parts, and it can induce, or it doesn't provoke a lot of shadows at the back of the module. So we can use that energy absorption at the back of the module. Next slide, please. Okay, this is our big portfolio of products that we offer down on the Caribbean region. The HAM 66D45 LB monofacial, 630 watt. That's great. With a 23.3% efficiency, light absorption efficiency of it. The JAM 72D42. It's a little bit bigger, longer. It doesn't affect. And the JAM 72D40. It's between these two, or it's the smaller one between these three ones. But the big thing, we maintain the width of the module. We're not making it bigger. We're making it longer. And as I was telling you, if only monofacial goes down to 550 watt per module, we're giving you the same dimensions with greater power bin, and we can compensate that weight that you're going to apply down to the structure. So as I was telling you, maybe they're not producing monofacial for 600, and there's only bifacial. Bifacial is your option. It applies, and it covers the necessities of the project or the client. I think this is the last slide I have. Next slide, please. You can scan and explore our bifacial module, scanning that QR code. That's all for my side. I hope I was not really skipping things or talking a lot. I think I I deliver the good information to you. So if feel free to give your questions on the chat.
All right, Pablo, thank you very much for that. To everyone, you can scan this code. It will give you a closer look at our bifacial module, a 360 view of our bifacial module for those who are not familiar with those panels. Now, also, Pablo, there are a few questions that were posed. I'm going to throw them out to you with our first one. Our first question, somebody asked, what would you recommend as the best reflective surface to make full use of the bifacial solar modules for the tropics for our
Okay,
region?
I will go down to I will not recommend or grass or metal sheets because it increases the temperature. I will not recommend stones or really uh, big particle size stones. What I have seen is that they use really small particle stones and they paint it with limestone in white, and they give maintenance to it every 1 or 2 months. They will spray this white powder at the back of, if it's ground mount. If it's on a planner on a plain rooftop, there's a lot of plastic reflective white sheets, or you can paint your roof white. That's the two main things that I can recommend, but it's more I can give it more back to the things that I do not recommend. Grass or really I don't know, black roofs or black paint. Also depends on the pitch that you use, because you need to have a lot of distance between each row to have this reflection type. Some in tracker systems, when you track, when the tracking moves, the back part of the module, well, the back row will reflect some light down to the back side of the front row, and that will give a lot of power gain. But in fixed structure, it also depends on the distance. Yeah, the distance, and using really reflective as white, or as I told you, there are some plastic sheets that are UV protected that can do this. Using metal or reflective metal will concentrate a lot of heat at the back of the module, and heat is really a bad friend of a photovoltaic process.
Great, great, great. All right. So our next question following this one is, how is it maintained, and what are the considerations? Are there any considerations to take into account? So how are the bifacial modules maintained? Is there any special way for them to be maintained compared to the monofacial?
Well, mechanical properties. I've seen that when I was installing bifacial on here in Mexico, they have a lot of resistance, and the prevention of micro cracks inside it's even greater than on monofacial. Having, as I told you, having an equal sandwich, an equal arrangement of layers give a lot of mechanical properties down to the module, so you can handle it with more, not not in a bad way, but it gives more resistivity inside the cell and the module.
Okay. All right, now for our third question, third and final, I'll take this one. Many persons were asking about how to become a distributor or sub-distributor. So what I'll ask you to do is to send us an email. And at the end of the session, there's also going to be a QR code for us. You can scan that, and that will give you direct communication with us. Also, our social media handle is in that QR code. So please stick around to the end. You'll see those slides, and you can scan those QR codes for email and or social media. We're going to be moving into our trivia session. So please, when you scan, leave both surname and first name so that we can identify exactly who the winner is. What we'll do, we'll give everyone about a minute to 2 minutes to scan, and then we'll begin. So remember, at the end of the session, we'll have our social media handle. You can scan that, and also our email for those who want to know how to become a distributor or sub-distributor. Also, if you have any special projects, um, commercial, industrial, utility scale projects that you want, our input and assistance on, you can reach out to us just the same.
Hi guys, Isaac Salmon have a question. How will you compare bifacial panels versus that of the sun tracking solar panels as it's related to storage and efficiency? So, Pablo, could you help us with this question, please?
Yes. It's how would you compare bifacial panels versus that of the sun tracking solar panels as it relates on storage and efficiency? Sun tracking solar panels, if you refer down to products that have 3-axis motion, those have a greater efficiency on the front side of the cell. The construction of sun tracking solar panels have as it says the name, it tracks the sun in 3 ways. So the front part, it's even more efficient, right? And also it has a mount post 3-way axis. So that will, in some instance, promote back shadow on the back part of those tracking systems. In a single axis, you do this, and you have rows at the back and in the front. So the reflective light that gives the back row to the back part of the module in the front row, it's even greater than the sun tracking solar panels. So that's a difference between them, and it relates more in storage. The solar tracking systems have in some instance, what I know is they have their own solar storage system. So it would absorb more the light. It depends on how the system is tracking sunlight. If it's perpendicular, it will give a lot of efficiency. Yeah, that's why it goes or in single axis or in a 3-way axis motion. So it depends more on the technology used, but for solar tracking sun tracking solar panels, efficiency will be on the front side. It will not differ or be different as the bifacial module. It depends on the way that they're tracking the sun. I don't know I was clear about that. If you have any more question about it.
I think that's all the questions we have. We have about 24 persons signed up for the trivia. So we will begin now. So we start right now. All right, so we are now done. And our winner is Mateus with 5 points. And we Isaac Salmon with 6 points to take second place. And K Baker with 7 points. So K Baker, you are our winner for this webinar session. And congratulations. K Baker, we need to know your first name and your information so we can send over your gift. But guys, remember to scan the information here, and you can leave us a message. You can get our information where you can reach out to us via email or mobile, and of course, connect with our social media. Please remember to do so. We'll have more events, more webinars coming up, live events for the Caribbean region. So stay tuned. You'll get that information from our social media platform. So please ensure that you follow us. And again, drop us an email as to what you want us to speak on in the next session. But thank you everyone for joining. We will, for the persons who have left their email address, we'll reach out to you with the added information that you requested. But thank you once again for joining us.